It's the My Michelle Live podcast.
My Michelle Live, SCI Tech Talk, taking the God story to a geeky place. Here's Michelle.
Oh, yeah, that's right. Well, today on this SCI Tech Talk, we're going to be talking about science, an amazing thing that science, every time you turn around, you find another amazing thing that science is able to do. But in those discoveries, in those whoa, aha moments, you can also see a deeper story. And we're going to be looking for the God story together. And in the midst of it, hopefully give you reasons to believe.
And now, Reasons to Believe.
So welcome with me, Dr. Fuz Rana, Vice President of Research and Apologetics at Reasons to Believe. Fuz is the author of some amazing books. And I tell this story all the time because sometimes we have new listeners, but I was at a science conference of Christian scientists, and I was sitting under one of his teachings, and it was if you've not worked out for a while, imagine going to a gym and suddenly you're with a Olympic training team and you're like trying to keep up. I'm in this conference and I am probably 5 sentences behind. I'm pretty impressed that I could even be there as we're talking about something, as Fuz was talking about something, I don't even remember what it was, but dealing with molecular biology. Now, I say that because, Fuz, you also write a host of books like Who Was Adam? Creating Life in the Lab, Humans 2.0, which is so fascinating. A few of those books are going to fit into our topic today. But you are able to not only wax poetic and go over the heads of most mortals, but you also have a way of relating and writing deep things in science that make us all understand it, but also understand a deeper story. And that's part of what you all do at Reasons to Believe. Dr. Fuz Rana, my old friend, thanks for joining us today, buddy.
Michelle, thanks for having me again. It's always fun to hang out with you.
Oh, absolutely. And this week, we're taking on a story that to me is fascinating because it's talking about growing artificial cells that behave and divide like natural cells. And the implications, think about that as you're listening or watching right now, the implications of that. If we can create cells, man-made cells, essentially, can we create man-made life? Can you? And you wrote a book on this, Creating Life in the Lab. You've also written the book, more recently, Humans 2.0, which has an interesting little diddly from a talk show host in Seattle in the beginning. Never mind. But you wrote that book as well, which kind of takes that creating life in the lab to the next level of, are we going to be able to transmigrate into humans 2.0? Can we not only create a new life, but can we meld that with who we are now and become some cybernetic, futuristic, superhero race? So much to take on. Fuz, can we just talk about what this story is?
Yeah. Well, what you're making reference to, Michelle, is the fact that as biochemists, as life scientists, we are developing such a fundamental understanding of how life works.
Okay.
And we also simultaneously are developing very powerful tools that allow us to manipulate living systems to the point that we are looking at taking control, quote unquote, of the evolution of life on Earth, including our own evolution as human beings, where we are looking to try to evolve human beings by melding technology with us to create, the post-human species. Or we're looking at going in the lab and being able to engineer novel, non-natural, synthetic life forms of our own design. And this raises, of course, all kinds of very interesting questions, scientifically speaking. It opens up opportunities for incredible technology, but it raises unbelievably profound questions that have ethical and philosophical and theological implications. And it even raises questions about what is our place as human beings in the cosmos.
Some of the implications of this story, and maybe we should just spell out this story first of all, are amazing medically, the things it can do for people. And, I think, correct me if I'm wrong, but I think oftentimes these kinds of discoveries come from two places. One, can we? And two, what can we do with it? From a place of betterment for all of the things that we can do. But I wanted to talk about this particular story that scientists are building an artificial cell that grows and divides like a natural one. Can you give us a little insight into what they're doing and what their thought process behind it is?
Sure thing. Well, this is work that really represents the latest milestone in a project that's been ongoing for at least 20 years. And this is work headed up by Craig Venter and his team of collaborators, most recently at the J. Craig Venter Institute. And their ultimate goal is to create this artificial cell that is a minimal life form that they can then use kind of as a chassis to add additional genes to create a wide range of microorganisms that can carry out all kinds of different functions, like serving as bioreactors to make pharmaceutical agents or vaccines, or to create biofuels or bioplastics. And so they really see this as the next revolution in technology, ushering us into what we might call the synthetic biology age. And so that work that's being reported is their latest, milestone in terms of creating this artificial minimal cell. And they really are very close to achieving what they set out to do 20 years ago.
Oof. So the behavior of these cells mimic what happens in real life by natural biological cells, correct? So
Yes, that's exactly right. Yes.
they divide. So are they alive?
I think they actually are alive. And part of the reason I say that is because of the way that Craig Venter went about doing this. So instead of starting from the bottom up, where he adds chemicals to create a chemical super system that begins to assume the properties of life, he's approached it through what's called a top-down approach, where he and his team have identified what they believe to be the minimum genome, which means the minimum set of genes that would be necessary for an organism to actually exist as a bona fide life form. And they discovered that it takes about 400 to 450 different genes in order for life to be possible. And so if you think of a genome as the set of instructions, the genes are portions of those instructions that specify the production of proteins, which are machines inside the cell that carry out certain operations. And so when you say that there's a minimum genome of 450 genes, it means that you need about 450 individual distinct proteins that are working together to carry out all the operations needed for an organism to exist as a life form. And through that process, we've discovered that you have to have the mechanisms in place to replicate that genetic information. You have to have the machinery in place to build proteins. You have to be able to build the cell envelope and maintain it, and then be able to harvest energy from the environment. And uh, what they've done is they've again created a synthetic version of this minimum genome, and they've used it to reboot an existing cell, transforming it into this artificial non-natural life form. So they really have created a bona fide artificial cell that truly is alive.
Okay. So I guess that goes back to some of the opining that you did in your book. What was it, 10 years ago? Forgive me if I don't remember right, Creating Life in the Lab.
That's right. Yeah. In fact, I talk about the work that Craig Venter had done up to that point in the process of trying to create an artificial cell. So in the contravening 10 years, he and his team have made significant strides towards actually creating this minimal cell.
All right. And we're looking at a time where it's almost as though we're climbing on top of the Tower of Babel and saying, hey, we can do anything, right? It seems like there is no limit to what man can do. So you are literally saying that man created life. So we're the new gods? Whoa, what's going on here?
Yeah, well, for those people who hold to a materialistic worldview, when they think about the work that's going on in synthetic biology, they really argue that this is really highlighting, our place in the cosmos, and that it really undermines the idea that there's anything really truly special about life or anything truly special about us as human beings, in the sense that we are able to create and manipulate life at will. That they argue that this is undermining, the biblical account of origins, where we need a creator, to bring life into existence.
Oh, but
And so,
wait, there's more. I mean, that sounds like a reasonable argument. I mean, truly, because come on, we're essentially making life, albeit it's a little blobby cell. You're not creating a pastrami sandwich or anything, and so don't go bragging quite yet. I mean, it is cool and all, but there is seriously, whoa, hello, more to the story. Look how excited she is, because it doesn't take a molecular biologist. It could just be a girl like me to say, well, wait a minute, they created this life in the lab. Doesn't that require a bit of intelligence? And by nature, wouldn't that be, I don't know, intelligent design?
yeah, well, you're extremely perceptive, and that was essentially the point of the book, Creating Life in the Lab, was
Yeah.
that, even though I've heard a large number of origin of life researchers say, look, if we can create even a simple cell in the lab, that means that it's all that much more likely that chemical evolution could happen, because there's nothing truly special about life. But the irony is that it requires enormous amount of ingenuity on the part of the researchers to be able to pull something like this off. As I mentioned, Craig Venter and his team of collaborators, which represent among the best scientists in the world, have been working 20 years on this project. And they probably have spent, I would estimate, on the order of close to $100 million to even get to this particular point. And there's Nobel laureates that have collaborated with Craig Venter throughout this process. And when as a biochemist, when I look at what they've done, it is really science at its very best. The level of ingenuity that they bring to the table is just absolutely remarkable. There's so much, they're so clever in how they develop the strategy that they've executed to try to create this minimal cell. And then it requires, and they're relying on really a couple of centuries of accrued scientific knowledge. And then it's, again, highly skilled scientists working on detailed protocols in the lab, performing careful manipulations under precisely controlled conditions to pull this off. So what they've done is, ironically, as you pointed out, demonstrated intelligent agency is necessary to bring about the creation of life. And so instead of undermining the biblical story, they really are strengthening the biblical account of origins.
Really, you can just logically say, in a nutshell, what are the chances that a couple of scientists just went out, got a few beers, spilt those beers, knocked over their garlic aioli as they're dipping their fries, and went, oh my gosh, we created life? That's really what we're saying in essence when we look at a completely materialistic view of the universe. But just like this tiny cell, the likelihood of creating it without intelligence is just, not happening. So I get that. But the other step is understanding a bit of what they did discover. I mean, they're able to break down this life, or this cell rather, in a pretty minimal way. And this is let's talk about what this cell is and what it isn't.
Yeah. Well, one of the things that is remarkable to me again, as a biochemist, is how complex life actually is, even in its bare minimal form. This organism, which again consists of a minimum genome that is producing just the core biochemical systems needed for that entity to again exist as a bona fide life form. uh, Even though it's a minimal cell, it's unbelievably complex, and we still don't fully understand everything that's going on in this minimal cell. They've identified what they believe to be the minimum genes that are necessary, but a third of those genes, they have no idea what they actually are doing in the cell. They know that they are essential, but they don't even know what they're doing. And when they created the first version of this synthetic minimal cell, and that work was published in 2016, when the cell divided, it was producing all these really bizarre, unusual shapes. And they discovered that they needed an additional 20 genes that, again, they're not fully sure what these genes are actually doing, in order for the cells to replicate and form regular spherical shapes. So even though they've identified this minimum genome, we still don't understand everything that is necessary for life in its minimal form. And so the complexity is astounding, and it's hard to envision how something like that could have evolved through chemical evolution when you think about how absolutely complex minimum life is.
That's what I wanted to get to as you're talking. I'm thinking, now wait a minute. If, let's just say, for the sake of argument, there is some entity, that there is some kind of designer up there, what does that say about their level of intellect, that we don't have weird shaped blobs that just didn't make the cut still floating around somewhere? That there wasn't just a hit and miss and a little trial and error, and let's see what we can oh yeah, that didn't turn out so well, that's no Fuz Rana right there, let's just try again, right?
Yeah, and in many respects, even though they're referring to this as a minimal cell, that really is a misnomer, because these organisms or these minimal cells, I should say, have to grow under highly specialized laboratory conditions where the researchers have created this growth medium that's supplying all of these nutrients that cells that could exist independently in the environment actually are able to produce.
Okay.
And so it's really a misnomer to say that this is really the minimum requirements for life, because they are essentially short-circuiting a number of biochemical operations that are critical for organisms to exist independently. So we know from surveying the genomes of organisms that can live independently in the environment that the minimum gene set for those types of organisms is somewhere between 1,500 and 2,500 genes, depending upon the particular environment that organism is living in. So what they've produced is really not truly minimum life. And so minimum life is even more complex than what they've made in the lab.
Oh my gosh. But it is astounding. What they've been able to do is astounding. But as you point out, if it's not even minimal of life, I think it's important to point out, because you know that the headlines in media are going to be, scientists have solved the problem of creating life. We just do. We're sensationalists, but that's not really what's going on here. We can say
No.
scientists have created life, and it creates all of these imageries, but then we dial it back and go, okay, here's what's really going on.
Yeah, yeah. I think, and this work is some of the most powerful evidence that we can bring to bear for a necessary role that a creator must play in the origin of life. And so again, and what I like about this work, towards that end, is we're not arguing that things appear to be designed because they look like they're designed, or we're not arguing that evolution can't explain it, therefore it's designed. But rather what we're saying is, empirically, we know what it takes to pull something like this off. An intelligent agency is a necessary, contributing factor to this work. And if that's the case, then why would we think intelligent agency wouldn't be needed if, again, life is emerging on the surface of the earth.
Let's talk about this on a practical standpoint, some of the extreme benefits. And well, I think you and I've watched a few sci-fi movies. We could probably imagine some of the dangers, but we could talk about those too.
Yeah, well, in many respects, I am I'm very excited about what this work represents in terms of the next wave of technology. Because the grand vision of people that are working in synthetic biology in their best moments is to envision creating these bioreactors that can take relatively inexpensive materials like carbon dioxide and ammonia and things like that, and feed them to microorganisms that can convert them into highly valuable products like medicines and vaccines and bioplastics and biofuels. And this technology is going to be produced through green processes. Some people even envision creating microorganisms that could remediate the pollution in the environment. And so this is really very exciting stuff that really is ushering in some exciting possibilities you know, for the future in terms of what this technology could deliver. But on the other hand, this is also very frightening stuff because, you know, we are right now having conversations about what is the origin of the SARS-2 coronavirus? Was it something that leaked out of a lab, right?
Oh
Well,
my.
that's right.
Yeah.
And so that's the concern that I think people have, is that, yeah, this is very powerful technology, but what if one of these synthetic, microorganisms gets out of the lab or out of the factory and winds up in the environment and suddenly does things that we would never have expected? The amount of damage could be really quite concerning. And of course, there are people that think about strategic defense and things like that are deeply concerned about the work in synthetic biology because they believe it may be laying out a roadmap for bioterrorists to
Oh, there you
use.
go.
Right. And so there's some very significant concerns connected to this technology.
Do you think that
So
technology could help me with these allergies? Because you're this is a little different. We've been on radio together for many years, and you're watching me here. But yeah, there are some really wonderful things. But yeah, of course there are some scary things. And in that, are we not essentially flirting with the possibility of playing God?
yeah, well, that's the when people ask the question, should we play God? My response is always, well, I don't think we have much of a choice as human beings who are made in God's image,
Ooh,
because we
ooh.
have to play God because we're made in God's image. And so I think the work that we see in synthetic biology really highlights the fact that we are image bearers. It provides, support for the fact that we are exceptional as human beings. There's no other creature that has ever lived that has ever been able to produce this kind of technology and this kind of capability. And I think we are able to do it uniquely as human beings because we bear God's image. But the real question is, are we trying to take God's place when we do this kind of work? And I think there are many scientists that are doing this work with with noble intent. But there are other people who really do see this work as justifying taking God's place. And that's when I think we really are concerned. And so instead of asking the question, should we play God? I think a better question might be, are we trying to take God's place? And, this is where the Christian worldview becomes so important because we have a realistic perspective on who we are as human beings. Yes, indeed, we are exceptional. We're image bearers. We're capable of incredible achievements that are positive and that are good. But we also recognize that we lack wisdom and that we also are plagued with this thing called sin that oftentimes causes us to take the best that we can do and turn it into the worst of things. And that's the real concern, I think, when it
Mm.
comes to these kind of advances.
I think something we need to delve into is how striking the biblical worldview is as we advance in science. And I want to do that in just a moment. But first, I want to tell you that if you're listening or you're watching live, you can be watching on our Facebook page, My Michelle Live, or on our website at mymichellelive.com, and ask questions. You can ask live of our guest, Dr. Fuz Rana, with Reasons to Believe. Joel was asking about the components of life that we can say, well, these scientists created life in the lab, but nothing comes from nothing. And I think what Joel is asking it about is the component that's needed to create this life. Where did they come from? So we're going to ask that of Dr. Fuz Rana in just a moment, but I have to give kudos to our product of the month. Science and technology has created, Fuz, one of my favorite things in the world. I don't know why we don't have these here in the United States, but I love a good bidet.
Shine where the sun don't. Tushy. It's got your backside at mymichellelive.com.
That's right. It's a spa for your bum, and you can find it at mymichellelive.com. It's under $40. Are you kidding? Or $50. What could be better? Anyway, Fuz, you still with me?
I sure am.
I had to go there. Anyway, from our listener Joel, what about the components that were already there to create this life that these scientists were able to recreate?
Yeah, Joel's asking a really perceptive question. And so I very much appreciate his point, because in effect, what Craig Venter is doing, as well as other people that are working in synthetic biology, is really not truly creating life in the lab from scratch, but rather what they're doing is kind of creating artificial cells by taking the biochemical systems that already exist and kind of piecing them together in a novel and original ways. Mm-hmm. But they're really truly not creating life from scratch. And this is actually highlighting the fact that the components that make up the cell display incredible properties, that they have these just right properties that make them ideally suited to support life, to be suitable for life. And so I even wonder if we truly are going to be able to create artificial cells from scratch because of just how well designed the biochemical systems are. But and so we have to factor that into the discussion when we talk about, have scientists truly created life in the lab from nothing? And the answer is no, they haven't.
Ouch. Okay, so let's put this in cooking terms. If I make a homemade cake from a box, I can add some really neat things and I can just take that cake to the next level, but I'm not really making it from scratch. If I take the flour, the eggs, mom's old German chocolate cake recipe, and I create that, that's considered from scratch. But if you really are going to make something from scratch, you would have had to have created the wheat in order to go into the flour. You would have had to create the chicken in order to go in, to produce an egg. It really, if you keep reducing, logically, you think maybe there is something to this God story. And what I wanted to get to in our final minutes together as we talk with Dr. Fuz Rana of Reasons to Believe. Fuz, the biblical worldview seems to work congruently with what we see more and more in science. Now, we would argue because that's true, but if you are not coming from that standpoint, it's Twilight Zoney. It's just like, whoa. But let's talk about that.
Yeah, well, in many respects, the more that I appreciate the biblical worldview, the more impressed I am, even though I am a Christian. Because in a sense, the biblical worldview creates a milieu that makes science and technology possible. And it provides powerful motivation to study the world around us and to turn that insight into technologies that are going to benefit humanity. I don't know that there's any other worldview that has that powerful motivation. But at the same time, the Christian worldview also has in place these parameters, these points of protection where we recognize that human beings are prone to folly, that we are sinful, that we can do things to undermine the sanctity and the dignity of human life. And I don't know of any worldview that gives you both that powerful motivation for science, but also that a powerful framework that ensures certain safeguards are put in place to make sure that that technology that comes from the scientific insight is used for the best and the highest purposes. So, to me, the Christian worldview has a whole lot to say to our culture, to our world, as we contemplate, should we develop these technologies? And if so, how should we use them?
Fuz, final question. This was a really interesting story, and especially so since you were already up on this 10 years ago. So it's nothing new to you. You're like, this is old news. Come on, people. But to me, as you talk about a biblical worldview, I think we would be remiss in not going a little bit past just the intelligent design factor of what took place in creating these cells, of what we see in the universe. It just seems to be logical. And that's maybe something that we can take on an academic level. If you're following me, we're not going all Sunday school out on anyone right now. We're just saying academically, that's what the evidence leads to. But what I did want to get to is something that you often do in your books, and Reasons to Believe, all of the scholars there, is that we can also see evidence, kind of like fingerprints, if you will, of what this intelligent designer is. And I wanted to just get your thoughts on that, because as a molecular biologist, you see those fingerprints in the extraordinary creation on tiny, tiny levels.
Yeah. Well, to me, when, you ask the question, who is responsible for the design that we see in the universe, if you bring to bear what we've learned from astronomy as well as what we learned in biology, I think it really narrows that designer to some entity that would be like the God of the Bible. Astronomy indicates that this creator must be transcendent, must exist outside the universe and be powerful enough to bring the universe into existence. And when we see design in the universe, design in living systems, that design indicates it's coming from a person that has purpose, and that everything that we see is designed for a purpose. And that purpose increasingly looks like it's the advent of humanity. And so, and the fact that we, again, see designs in biochemistry that are so similar to the designs that we produce as human beings suggest that there is a resonance between our mind as human designers and the design produced by this, transcendent being. And to me, this fits the biblical view of who human beings are, but it also fits the biblical view of who God is. And it tells us that this God has made us for a purpose. And, to me, what's mind-boggling is that purpose is for us to know him and to be in a relationship with him through the person of Christ. What an amazing thing for me as a scientist to think that the fingerprints I see for that creator are just pointing to the fact that I can have a relationship with the God that brought all this into existence that I marvel at.
So we've gone from just a little cell to absolute purpose in our lives, a hope in the midst of all of this craziness. That's something amazing. And that's kind of why I love taking on science and technology on My Michelle Live, because it really does lead us back to the God story. And excuse me for just a moment. I'm going to grab one of your books off my shelf. This is Humans 2.0. A great book that you might want to pick up. I was going to try to find Creating Life in the Lab. Oh, I have that one too. These are some of my favorite books. That's why they're so easy to grab. That's another one of Dr. Rana's books. I'm not there reading romance novels, people. These are the books. In fact, oh my goodness, was it like 4 years ago I came down to see you all there at the headquarters of Reasons to Believe in Southern California. These folks were so amazing. They had a beautiful spread there. I got to sit down with these brilliant minds of the scholars there. And then they took me to their bookstore and said, pick something out, anything you want. Dude, I was like a kid in a candy store. I'm like, my eyes were this big. And I'm thinking to myself, don't be greedy. But no, seriously, the books that you can find them at reasons.org. You can go through a link on My Michelle Live. I am telling you, having a better understanding in a logical way of the universe and of science, that's what they're all about. And I love it. And it always comes back to the God story. And that's why we are such good friends, right? Yeah. It's so much fun to have you, Fuz. It really is. Thanks for making time for us today.
Oh, my pleasure. It's again, I always enjoy talking with you, Michelle. So thanks for being so welcoming.
Big hi to everyone there, all right? Love those guys there. Try not to dance.
More SciTech Talk at mymichellelive.com.